This is the Rockwell Collins Capstone project. I'm Keenan Salveson along with my teammates John Mines, Kyle Ryan, John Schutz, and Kevin Thomas. Our project is the Ethernet test tool. This tool is intended to determine if a router is malfunctioning. An example of the sort of malfunctions we test for are when specific bits in the payloads of packets may be flipped, or perhaps when using a particular port, bits become corrupted. Our tool is comprised of three portions: sending, receiving, and log differentiation. The sending portion is responsible for sending UDP and TCP packets while logging the contents of their payloads. The receiver then receives the packets and logs the payloads as well. Finally, the diff portion compares the two log files to search for discrepancies. First off, here's an example script file that the sender follows. We define the port we wish to send on with the send port keyword. Next, we define the port we wish the receiver to listen on with the receive port keyword. With the address keyword, we specify where to send the packets. In this case, we're using the local host. We define the size of the packets payloads with the size keyword. With the delay keyword, we specify the length of time in milliseconds to pause between each packet send. Then we specify the type of packet we wish to send, that is UDP or TCP, with the type keyword. Using the payload-t keyword, we can specify the contents of the packet to send. We can send all zeros, all ones, or random data. We also have the payload-f keyword for specifying a text file that defines the hex values we wish to use for a user-defined payload. Finally, we use the send keyword with the amount of packets we want to send. There's no specific order these keywords have to be defined in, but each keyword has to be defined before using send. Here's an example payload file. All that is required is that all the values that are defined are hex. We're first going to set up our receiver to accept UDP packets. To create a receiver, we just use the -rp argument followed by the port we want to receive packets on. Next, we start up our sender using the -s argument and the -f argument followed by the name of the script file we want to use. Now that the sender is finished, we're just going to force stop the receiver. Notice that in our folder with the jar that we've been running, there's now a logs folder. In it, we see we have sender and receiver logs. We're now going to perform the same process, but using TCP instead. All that has changed is the type keyword, which is now set to TCP instead of UDP. Additionally, our receiver has the -t argument to specify it will receive TCP packets. We will point our sender to the script-tcp script file and force stop the receiver when it finishes. Once again, our log folder has more files in it. The logs are difficult to compare by eye, so we have our Diff Tool to help the process. To run the Diff Tool, merely give the -d argument followed by both logs file names. Here, you see nothing went wrong, so we'll modify one of the logs to see what happens. This time, we see the line numbers that failed to match relative to the first of the 2 logs that we specified. Finally, I'm going to show that a single sender is capable of changing the ports and types of packets it sends with a single script file. This file is the same as the other 2, except we now switch to TCP halfway through, as well as modified the delay and the size values. Keep in mind, all of the values can be modified in the script, including address, but for the sake of this video, we'll keep to the localhost. Our logs have been generated, showing the tool works. Thank you for watching our video.